Hello everyone. Today's video, we're going to learn about identifying covalent and hydrogen bonds. So let's start with hydrogen bonds first. So what is a hydrogen bond? A hydrogen bond is a weak interaction where it is not a strong interaction like covalent and ionic bonds. And a hydrogen bond is basically when the positive charge on one atom is attracted to the partial negative charge on another atom. So hydrogen bonds can happen between water molecules, but keep in mind that hydrogen bonds can form between non-water molecules as well. So remember, we said that the hydrogen bond is when the positive charge on one atom is attracted to the negative charge on another atom. So if we have water, for example, which is H2O, and we have ammonia, which is NH3, a hydrogen bond can form between those two molecules. So let me draw water, which is H2O. I have drawn H2O. So the green equals the oxygen atom, and the blue equals the hydrogen atom. Over here, the orange equals the nitrogen atom, and the blue, like in water, equals the hydrogen atom. Okay, so we drew H2O and we drew NH3. So if we look at this water molecule, we have two hydrogen atoms and one oxygen atom. Between the hydrogen and oxygen atom, which one is more electronegative? Is the hydrogen atom more electronegative, or is the oxygen atom more electronegative? Well, the oxygen atom is more electronegative. Electronegativity is how strong the atom can attract electrons to itself. So if we go to our periodic table, electronegativity increases as you go from left to right on the periodic table, and electronegativity increases as you go from down to up on the periodic table. So since hydrogen is at the complete leftmost of the periodic table, and oxygen is very close to being on the rightmost of the periodic table, oxygen has a higher electronegativity than hydrogen. So this means that the oxygen atom is more electronegative. This means that the oxygen atom has a stronger attraction to electrons. Now let's go back to our H2O molecule. Since we said that oxygen has a higher electronegativity than hydrogen, which means that the oxygen atom has a stronger attraction to electrons, the oxygen atom is more partially negative than the hydrogen atom. So I'm going to put the partially negative sign on the oxygen atom. So the green is the oxygen atom, and I'm going to put a partially negative. So this sign essentially means partial, and this is a negative sign. Therefore, since the oxygen atom is negatively charged, the hydrogen atom is positively charged. So I'm going to put a partial positive sign on both of the hydrogen atoms. So partial and then positive, and this is also the other blue circle is also a hydrogen atom. So partial, then positive. So partially positive charge. And between the oxygen and hydrogen in the water molecule, it is not a hydrogen bond forming. So between the oxygen and the hydrogen bonds, these are covalent bonds. So in general, the type of bond depends largely on the electronegativity difference between the atoms. So I'll write a new page. So electronegativity. So if the electronegativity difference is greater than 2.0, then it's an ionic bond. If the electronegativity difference is between 0.5 to 1.7, then it is a polar covalent bond. And if the electronegativity difference is less than 0.5, then it is a nonpolar covalent bond. And again, all of these values are just approximates. So at times, the electronegativity difference could be 0.6, and it is a nonpolar covalent bond. But for the purposes of this video, we are going to go with these numbers. So the electronegativity of hydrogen, it is a bit blurry, but it's written on this periodic table. So it's 2.20. So hydrogen is 2.20. The electronegativity of oxygen that is written on this table is 3.44. So the difference in the electronegativity of the hydrogen and oxygen is 3.44 minus 2.20 equals 1.24. 1.24 is between 0.5 and 1.7. So 1.24, which we calculated over here. So 1.24 is between 0.5 and 1.7. So the bond between the hydrogen and oxygen is a polar covalent bond. Since it is a covalent bond and not an ionic bond, we have to use the partial positives and partial negatives rather than only positive and negative. So in covalent bonds, electrons are shared between the atoms. So covalent electrons are shared. So a partial positive and a partial negative, this means partial, these symbols mean partial. So the partial positive and partial negatives are necessary. In a polar covalent bond, the electrons are shared between the atoms, but are not shared equally. Now let's go back to our example. So covalent and ionic bonds are stronger than hydrogen bonds, as we've mentioned in the beginning of this video. So we know that since the bond between the oxygen and the hydrogen, same thing over here, between the oxygen and the hydrogen. So we know that the bond between the oxygen and the hydrogen is a polar covalent bond. So this is a strong bond. Now let's focus on the partial charges. A positive charge on H in the water molecule, so this is the H and this is the partial positive charge. So that's going to be attracted to a negative charge of an atom in ammonia. So over here is ammonia, and this hydrogen has a partial positive charge and is going to be attracted to a partial negative charge in ammonia. Let's figure out NH3, which is ammonia. So let's figure out which atom is partially positive and which atom is partially negative. So if we go back to the periodic table that has the electronegative, if we go back to the periodic table that has the electronegativity of the elements. So hydrogen over here, same thing as before, is on the leftmost side, while nitrogen is on the right side. So nitrogen has a higher electronegativity than hydrogen. So you can also see, as mentioned in the table, that hydrogen has electronegativity of 2.20. So that's the number written over here. And nitrogen has an electronegativity of 3.04, which is the number written over here. It's a little hard to read, I know it's blurry, but basically that's what it says on this table. So nitrogen has a higher electronegativity than oxygen, or nitrogen has a higher electronegativity than hydrogen. Additionally, if we try to find out if the nitrogen and hydrogen bond is a covalent or ionic bond, we can find the electronegativity difference. So 3.04, which is the electronegativity of nitrogen, minus 2.20, which is the electronegativity of hydrogen. So this equals 0.84. So 0.84 is between 0.5 and 1.7. So I'll write 0.84 as well. So basically we found 0.84 over here. And when we go back to our electronegativity chart, I guess, so to speak, 0.84 is between 0.5 and 1.7. So this means that the bond between the hydrogen and nitrogen in ammonia is also a polar covalent bond. Remember, determining if the bond is covalent or ionic is important to determining whether to write partial positive or partial negative. Since the bond between hydrogen and nitrogen is covalent, we will write that the hydrogen atoms have a partial positive charge and nitrogen has a partial negative charge. The partial negative charge on a nitrogen is pulling the electrons away from these hydrogens and giving the hydrogen atoms a positive charge. So because we know that nitrogen has a higher electronegativity than hydrogen, we know that nitrogen is going to be the one with the partial negative charge, and the three hydrogens are going to have a partial positive charge. And remember, it's important to write partial because we figured out it was a covalent bond. The partial negative charge on this nitrogen is pulling the electrons away from these three hydrogens, and therefore is giving the hydrogen atoms a positive charge. Because remember, electrons are negative, and when you take away electrons from an atom, the atom becomes more positive. The hydrogen atoms from the water molecule, which is this and this, so these are partial positively charged. So it needs to attract to the nitrogen atom from ammonia. Since the nitrogen atom from ammonia is partially negative. Remember, partial positives and partial negatives attract, since opposite signs attract. The bond between the hydrogen atom of water and the nitrogen atom of ammonia is the hydrogen bond. So this is the bond, and because there's not enough space, I'm just going to write it over here. So this is the hydrogen bond. So as we mentioned at the beginning of this video, this hydrogen bond is weak and transient. So transient means that it is not permanent, where the two atoms can attract each other, then be broken and move away from each other, then attract, then break, then attract, then break, etc. So this hydrogen bond is very, very weak compared to the covalent bonds. So therefore, the bond between the hydrogen oxygen atom in the water molecule, so this bond, so the bond between the hydrogen oxygen atom and the water molecule, which is a covalent bond. So remember, as we mentioned in the beginning of this video, that these are covalent bonds, is stronger than the bond between the hydrogen atom and the water molecule and the nitrogen atom and the ammonia molecule, which is the one that I am bolding over here. So this is the hydrogen bond. Now, let's see another example. Let's say we have two water molecules. So water is H2O, and we have two of them, so I'm going to draw a second one. And we'll use the same color scheme as last time. Okay, so we have the two water molecules drawn. So we mentioned that oxygen has a partially negative charge and hydrogen is partially positive charge. So let's label that in the diagram. So oxygen is the green. So oxygen has a partially negative charge, as we mentioned earlier, and the hydrogen atoms, both of them have a partially positive charge. Same thing in this diagram. So oxygen, partially negative, remember the partial because it's a covalent bond. Hydrogen atoms, partially positive charge. So we have it labeled in our diagram. And we also mentioned that positive and negative charges attract, hence opposites attract. So the negative oxygen atom of one water molecule is going to form a hydrogen bond with the positive hydrogen atom of the other water molecule. The oxygen atom of one water molecule, which is partially negative, is going to form a hydrogen bond the oxygen and hydrogen bond within the water molecules. So this bond, this. So the hydrogen and oxygen bond within the water molecule is a covalent bond. So I'll just label that over here. So covalent bond. And this is a strong bond. Covalent bonds are strong bonds. However, the oxygen atom from one molecule bonding to a hydrogen atom from another water molecule is a hydrogen bond, which is a weak bond. So let's introduce some terminology in that case. So a bond happening between molecules, where one water molecule has a bond with another water molecule, that is called intermolecular forces. Intermolecular happens between, and it's generally weak. Intermolecular forces are generally weak, so the hydrogen bond, which is happening between the molecules, so this is the hydrogen bond that I wrote in red. So the hydrogen bond, which is happening between molecules with one water molecule and another water molecule, this is an intermolecular bond, or an intermolecular force. However, intramolecular force is inside. So it's inside the molecule. So the intramolecular force in this case is the bond between oxygen and hydrogen atoms between one water molecule. So this is the intra. So is this. This is the intra because it's bonds within the molecule. So intra, and this is also intra. So these are covalent bonds, the ones I just highlighted in yellow, the hydrogen and oxygen bonds within the water molecule. These are covalent bonds. So these are strong. So intramolecular forces are generally strong. So these intermolecular forces are generally stronger than the intermolecular forces. Okay, and that is it for this video. Thank you so much for watching. If you like this video, please subscribe to our channel and please follow our Instagram STEM Guide channel for more updates on when new videos in science, technology, engineering, and mathematics will release. Thank you.